Hello everybody, what is up? I'm finally back to study some more cool, fun, bad, boring, amazing things. So let's get started. I am soon going to do this thing. I'm done with AWS part for today. Let me check my mobile's battery. It's 35. I will go and put it on the charger. I'm back now. Okay, my Wi-Fi is working. That's very good to know. Now we start learning about our beautiful Docker. Because why not? Sorry for delay. I just got some amazing messages. Let's get back. Boom, humans. So I have a copy to note stuff because I'm trying to study stuff. Blah blah blah, random bullshit. So let's get started. Now, first of all, wanna supervise me learning Docker. And now let's go to the work, real work. We will need to find a message which have a link, and it is from out of context Shishui, aka Topic Sound. So this is the video which we will be watching. It is really an amazing video made by
Hello and welcome to
Nana. I don't really know her, but I watched this video till like here, and it is good so far. Amazing video. So yeah, let's see. Let's write some stuff down so I will actually feel like studying. I mean, I should get the vibe that I'm studying, right? Because my memory is not good enough to remember these things for long term. Like, if I'm reading something, I'm understanding it, all good, amazing, I know it all, I can make it. But few days later, few weeks later, shit, I don't remember studying that thing at all. So, what I do it? Now, first of all, let's start it from the very start. Let's see. I have one,
we'll
two,
talk
three,
about what a
four.
container is and what
I have like 4 5
problems it
pages,
solves.
so I will
We will
go back
also look at a
a
container
bit more. I'll
repository,
go
which
from
is
here.
basically a
Sounds
storage for
beautiful.
We'll see how containers
So pretty much, let's start with I need a sharpener, or it is called
and
a
also how
sharpener.
it
I don't
solves
really
some
know,
of the
man.
problems that we
I
have
think I
in
have it.
deployment process of applications. So let's dive right
So I
into
have a
it. What a
pencil
container
box.
is. A
Sorry,
container
it's
is
a
a way to
geometry
package
box.
applications with everything they need inside
Man,
of that
feels
package,
like school.
including the dependencies and all the configuration.
Look at this pencil, man.
And that package is
Wait a
portable,
second.
just like
Pause this video and let me just show you all this amazing pencil. Give me a second. Just give me a second. I'll open my camera. Where is my camera? Let's go to live stream. I will add my camera right now. Looking good. So can I hide it? I can hide it. Yeah. Let me put it right here. It is really scary to the. I will put it in the middle. All right. So can you look at this? This is not really a nice. Lighting is not very good. Let me just turn the lights on. I hope I will not show my face by mistake. Don't want people to get scared, you know. Okay, that's the best I can do for now. So give me a minute. Can you see it now? Well, yeah, it's good. It's cool. That's pretty much it. Let's make it small because in case if I open it by mistake, you won't be able to see much. And now lock it and let's get started. So you can see the pencil is quite sharp, feeling really hyped up. Gotta start the work. I will try to write a summary of everything I hear so that I don't know, man. I'm just
Hello and
trying to do
welcome
some
to
fun
this
stuff.
complete Docker course.
Okay.
By the end of this course, you'll follow.
Okay.
The course is a mix of what you
I
cover
remember all
in
of this.
virtual machine learning itself.
So what is Docker? What is
Also,
the
we'll
container?
understand the debug all the made through a completed
Oh, okay.
code to employ our tools. We will also look at a container repository, which is basically a storage for containers. We'll see
Okay.
how a container can actually make the development process much easier and more efficient, and also how they solve some of the problems that we have in the deployment process of applications. So let's dive right into it, what a container is.
Okay.
A container is a way to package applications with everything they need inside of that package, including the dependencies and all the configuration necessary. And that package is portable, just like any other artifact is. And that package can be easily shared and moved around between a development team or development and operations team. And that portability of containers plus everything packaged in one isolated environment gives it some of the advantages that makes the development and deployment process more efficient. And we'll see some of the examples of how that works in later slides.
Okay.
So as I mentioned, containers are portable, so there must be some kind of a storage for those containers
Yeah,
so that you can
totally.
share them and move them around. So containers live in a container repository. This is a special type of storage for containers. Many companies have their own private repositories where they host or where they store all the containers, and this will look something like this, where you can push all of the containers that you have.
Okay, okay.
There is also a find any application container that you want. So let's head over to the browser and see how that looks like.
Alright. I've
So
had
if
in
I
the browser
here
as
search
well.
for Docker Hub, which is the name of the public repository for Docker, I will see this official website.
Ooh, that's
So
cool.
here, if you scroll down, you see that there are more than 100,000 container images of different applications hosted or stored in this Docker repository.
Ooh.
So here you see just some of the examples, and for every application there is this official Docker container, Docker container image. But if you are looking for something else, you can search it here. And I see there is an official image for, let's say, Jenkins. But there's also a lot of non-official images or container images that is where. Now let's see how containers improve the development process.
I totally
by
remember this
specific
part. I will have to skip it.
And the operations team will handle.
Let's move on to what
setting up
is
the environment.
container. Alright.
Now that you know what a container concept is, let's look at what a container is technically.
Okay, for sure.
So technically, a container is made up of images. So we have layers of stacked images on top of each other, and at the base of most of the containers we would have a Linux-based image, which is either Alpine with a specific version, or it could be some other Linux distribution. And it's important for those base images to be small. That's why most of them are actually Alpine, because that will make sure that the container stays small in size, which is one of the advantages of using a container. So on top of the base image, you would have application image, and this is a simplified diagram. Usually you would have these intermediate images that will lead up to the actual application image that is going to run in the container. And of course, on top of that, you'll have all this configuration data. So now I think it's time to dive into a practical example of how you can actually use a Docker container and how it looks like when you install it and download it and run it on your local machine. So to give you a bit of an idea of how this works, let's head over to Docker Hub and search for PostgreSQL.
Okay, let's do it. Let me increase the video quality as well. Let's go 720.
See some of the versions. Let's say I'm
Docker Hub. Sorry, Docker Hub.
For older version, I don't know, 9.6 something. So I'm going to hold that one. So this is a Docker repository, so that I can actually.
I use CentOS. Learn Linux first. What does that mean? CentOS. Alright.
Actually go ahead and pull the containers from the repository.
Oh, we're on
directly.
16 now.
And because
Oh,
it's
she's
a
from
public
2 years ago.
repository,
Okay.
I don't have to log into it, I don't have to provide any authentication credentials
Yeah.
or anything. Doing or configuring Docker.
Oh, do I even have Docker?
On my terminal,
I totally remember installing it, so yeah, I do have it. Beautiful.
I can just do Docker. Cool. I can even do Docker run, and then just copy the image name. And if I don't specify any version, it will just give me the latest. But I want a specific version, so I'm gonna go with 9.6.
I think I should make one.
Just to demonstrate.
Let's see.
So
Docker run
I can
Postgres
provide
and-
the version.
Okay. I will need to run the Docker daemon because I have removed the auto start thing, of course. What should I call it? Let's make a folder called test. Let's go and test, and I'll do the stuff here. Alright. Starting the Docker engine. Beautiful. Do it. Do it. You did it. Let's delete this thing. I don't remember all of that. I don't have that good of a memory. Docker PS. Amazing.
This with a
So she's doing Docker run
colon, and I can start
Postgres.
run. So as you see, the first line says unable to find image locally, so it knows that it has to go to Docker Hub and
Yeah.
pull it from there.
Should I do it as well?
And the next
Oh wait, I
line
forgot.
says,
I have a live stream. I have to read the chat. Oh no chat, so no problem. And it's also a problem because we have no chat. That's not really nice, but okay.
pulling from library Postgres.
Okay.
And here you see a lot of hashes that says downloading.
Yeah.
And this is what I mentioned earlier, which is Docker containers or any containers are made up of layers.
Yeah.
Right? You have the Linux image layer, you have the application layers, and so on. So what you see here are actually all those layers that are separately downloading
That's quite
from
cool.
the Docker Hub online machine. Right?
Okay, something happened. Digest status. Download newer image for Postgres 9.6. I don't really know what's the Postgres password. But anyways, let's install a newer version. Like, let's do 15.3. How do I delete, by the way? Docker run Postgres. What was it? 15.3. Let's do it. 15.3. How to delete Docker container CLI. Dun, dun, na, 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 na. Docker stop Docker RM. Okay. How to get list of available Dockers. Sorry. Docker. Okay, so that is the command. Docker container ls. That's smart. I hope that works. Okay, it's taking quite some time to install. That's not really nice.
And the advantage of splitting those applications in layers is that actually, for example, if the image changes or I have to download a newer version of Postgres, what happens is that the layers, they're the same between those two applications. Two versions of Postgres will not be downloaded again, but only those layers that are different. So for example, now it's gonna take around 10 or 15 minutes to download this one image because I don't have any Postgres locally, but if I does, some layers already exist on my local machine.
Okay.
So now you see that it's already logging because this command that I ran here, the docker run with the container name and version, it fetches or
Database is uninitialized and super user password is not specified. You must specify this to a non-empty value for the super user. For example, password is this on Docker run. Okay. You may also use host auth method to allow all connection of password. This is not recommended. See the damn thing. Okay, I'll see the damn thing. Let's shift it over. I have never used Postgres, so I don't know shit. Um, um, let's do it. I will do -e and let me just copy this damn thing is equals to, let's try test and let's see how it works. Database is uninitialized, super user password is not specified, you must compare the progress one non-empty value, blah 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 and blah. Docker run, paste it, enter. I literally did, man. Will you stop lying?
so it pulls the container, but it also starts it. So it executes the start script right away.
Okay, I will just make an environment variable then. Set, okay. Set, shit man. Set, paste, test, enter. So will that work? Let's find out. Echo %% postgres dash enter. Nothing happened. Password. Wow. Why is this thing so beautiful?
As soon as it downloads it, and here you see the output of the starting of the application. So it just gives some output about starting the server.
Okay, this thing is being a bitch now.
Configuration.
This command prompt is such a bitch. I will need to restart it, I guess. Let's go in local disk E cd/learning/docker/test. I want to stay here for, I don't really know why. Docker run Postgres 15.3. How do I initialize it then? I don't know.
Stuff. And here you see database system is ready to use internet.
Why is my database system not ready to use to do whatever the fuck? How to initialize Postgres Windows. Oh, let's try it out, my friends. For port I will do like 4000. Dash V defines or allocates the volume or file system for the container. Dash D runs the container as a backend service or in a detached mode. I don't know. Let's see how it goes. Okay, I'll copy the whole damn thing. Alright. What about this? Let's get back to the video.
And once you start it. So now let's open the new tab and see with Docker PS command you can actually see all the running containers.
Okay.
So here you see that Postgres 9.6 is running, and it actually says image. So this is another important thing to understand when we're talking about containers. There are two technical terms, image and a container, and a lot of people confuse those two, I think, and there is actually a very easy distinction between the two. So image is the actual package that we saw in one of those previous slides. So the application package together with the configuration and the dependencies and all these things. This is actually the artifact that is movable around, is actually the image. Container is when I pull that image on my local machine and I actually start it, so the application inside actually starts, that creates the container environment. So if it's not running, basically it's an image, it's just an artifact that's lying around. If I start it and actually run it on my machine, it is a container. So that is the distinction. So here it says the active running containers with a container ID, image that it's running from, and some entry commands that it executed and some other status information. So this means that PostgreSQL is now running on my local machine. Simple as that. If I were now to need, let's say, another version of Postgres to run at the same time on my local machine, I could just go ahead and say, let's go back, and let's say I want to have 9.6 and 10.10 running at the same time on my local machine. I'll just do run Postgres and run. Again, it doesn't find it locally, so it pushes. And this is what I actually explained to you earlier, because it's the same application but with just a different version. Some of the layers of the image are the same, so I don't have to fetch those again because they are already on my machine. A little bit of time load so that we have. Now you see I have Postgres 9.6 running in this command line tab, and I have Postgres version 10.10 running in the next one. So I have two Postgres with different versions running, and I can actually output them here.
Cool. Now the question is,
both of them running, and there's no conflict between those two. Like, I can actually run any number of applications with different versions, maybe the same application, with no problem at all. And we are gonna go through how to use those containers in your application and the port configuration and some of the other configuration stuff later in this tutorial when we do a deep dive. But this is just for you to get the first.
By the way, why does it say deep dive?
In this tutorial, when
is YouTube down?
We do a deep dive, but this is just for you to get the first visual image of how Docker containers actually work, how they look like, and how easily you can actually start them on your local machine without having to implement a specific version of Postgres application and do all the configuration yourself. when I first started learning Docker, after understanding some of the main concepts, my first question was, okay, so what is the difference between Docker and Oracle?
What the fuck is an Oracle?
VirtualBox, for example. And the difference is quite simple, I think. And in this short video, I'm going to cover exactly that. And I'm going to show you the difference by explaining how Docker works on an operating system level and then comparing it to how virtual machine works. So let's get started. In order to understand how Docker works on the operating system level, let's first look at how operating system is made up. So operating systems have two layers: operating system kernel and the applications layer. Yeah. So as you see in this diagram, the kernel is the part that communicates with the hardware components like CPU and memory, etc. And the applications run on the kernel layer, so they are based on the kernel. So for example, you all know Linux operating system, and there are lots of distributions of Linux out there. There is Ubuntu and Debian, and there is Linux Mint, etc. There are hundreds of distributions. They all look different, so the graphical user interface is different, the file system is maybe different. So a lot of applications that you use are different because even though they use the same Linux kernel, they use different, or they implement different applications on top of that kernel. So as you know, Docker and virtual machine, they're both virtualization tools. So the question here is, what parts of the operating system they virtualize? So Docker virtualizes the applications layer. So when you download a Docker image, it actually contains the applications layer of the operating system and some other applications installed on top of it, and it uses the
Let's see what topic will say.
Kernel of the host, because it doesn't have its own kernel. The VirtualBox, or the virtual machine, on the other hand, has the applications layer and its own kernel. So it
like a
virtualizes the complete operating system, which means that when you download a virtual machine image on your host, it doesn't use your host kernel, it puts up its own. So what does this difference between Docker and virtual machine actually mean? So first of all, the size of Docker images are much smaller because they just have to implement one layer. So Docker images are usually a couple of megabytes. Virtual machine images, on the other hand, can be a couple of gigabytes large. A second one is the speed. So you can run and start Docker containers much faster than the VMs because every time you start them, they have to put the operating system kernel and the applications on top of it. The third difference is compatibility. So you can run a virtual machine image of any operating system on any other operating system host. But you can't do that with Docker. So what is the problem exactly? Let's say you have a Windows operating system with a kernel and some applications, and you want to run a Linux-based Docker image on that Windows host. The problem here is that a Linux-based Docker image might not be compatible with the Windows kernel. And this is actually true for the Windows versions below 10, and also for the older Mac versions, which, if you have seen how to install Docker on different operating systems, you see that the first step is to check whether your host can actually run Docker natively, which basically means is the kernel compatible with the Docker images. So in that case, a workaround is that you install a technology called Docker Toolbox.
Now let's try to understand what he did. We do docker run and we give it some name, and then first of all we had an environment variable called pg data, that's equals to slash var lib postgres data pg data, I don't know. Then we set the password, then we do something called dash v, and of course I have no idea what the hell is dash v. So I would like to go here and let's see what dash v is. I forgot. Let's try to find that thing again. Okay, there we go. So dash v is, what the fuck is it? What? So my laptop is being a bitch again. Look at the memory usage. Can't help it. Defines or allocates the volume or file system for the container. Oh, okay. So we did custom mount var live postgres data. Okay. And why the hell that thing worked? Meanwhile, I will just Google search it as well, because sometimes topic gets um, a bit less interested in the topic, I guess. I don't know. Let's wait for him. Meanwhile, let's do that. That's
Flux,
okay.
which abstracts away the kernel to make it possible for your host to run different Docker images. So, in this video, I will show you how to install Docker on different operating systems. The installation will differ not only based on the operating system, but also the version of the operating system. So you can actually watch this video selectively depending on which OS and the version.
I will watch it
OS.
all, man. Okay. Alright, let's do it again, I guess. Let's rename the damn container, my friends. Docker rm bang. Now let's run it. So it is started, but I have a feeling it started on probably started on 5432. I am not sure, man. Let's see what. Let me try to understand what we have. So Docker doesn't care about things after the image name. And he gives the name at the end. Whereas here he gave the name not at the very end of it. Probably. What was I doing there? So this thing is ready, it is started. I don't know what to do now. 543 blah blah blah. Okay, let's go here. Let's go on localhost 5432. What happens? Nothing. Interesting. I think these might be the failed ones. All of these. Oh, it is on port 4000. Damn, my bad. But we cannot really connect to it like a website. That makes sense. Let's delete all of these. Oh, I can select them and delete them at once. That's very, very neat. Delete. Yes. So amazing, man. So amazing. Now I can go on volumes. This is in use, this is not in use. Let's delete that one. Click on the first volume and see. Let's delete all of. Wait. Let's click on it. Ooh. That's what it says in the app. Let's go back to container, delete this container and go to volume. We have no volume. Beautiful. Let's go back here, paste. So we are doing Docker run. We are giving it a name. We are choosing the PG data. Not sure what the Postgres data mean. Then we are setting a password. We are setting the volume and we are starting it up, I guess. I think he might say that for the port 4000 port on a PC is being mapped into 4000 of the container. Ooh, I don't know what that means. Let's wait for it. Which command I should run? That's all I want to know, man. I have no other desire. Alright. But Postgres is running inside 5432. Okay, sounds cool to me. So let's try to run this command and see how it goes. I think it worked. I hope it worked. Let's try to. I don't really think that that's how we try to see if it is working, but I will try to see and find out. You can leave it -p. Okay. Alright. Cannot reach this page and this page is not working right now. 4000 is up. That's the moral of the story. Alright. Postgres is up. Now I will watch the rest of the video and get back to you as soon as I get stuck. And let's get started.
Ways you have. I will show you how to find out which installation step applies to you in the before installing section, which is the first one. So once you find that out, you can actually directly skip to that part of the video where I explain that in details. I will put the minute locations of each part in the description part of the video, and also I will put all the links that I use in the video in the description, so that you can easily access them. Also, if you have any questions during the video or if you get stuck installing the Docker on your system, please post your question or problem in the comment section so that I can get back to you and help you proceed.
Okay.
Or maybe someone from the community will. So with that said, let's dive right into it.
What the hell says Dove?
So if you want to install Docker, you can actually Google it and you get official documentation of Docker. It's important to note that there are two editions of Docker. There is a community and enterprise editions. For us to begin with, community edition will be just fine. In the Docker community edition tab, there's a list of operating systems and distributions in order to in here, and we see the documentation of other ones as well. On your Mac or Windows and Windows, the hashtag in order to set requirements, if you have some requirements there or what to know before you install. For example, one thing to note is that Docker natively runs only on Windows 10.
Okay.
So if you have a Windows version which is less than 10, then Docker cannot run natively on your computer.
That's quite tragic.
So if your computer doesn't meet the requirements to set up Docker, you basically just have to install them in a Docker. So if that, as you see here, there are two channels that you can download. Thing to consider: if you have an older version of Mac, the software or the hardware, please go through the system requirements to see what Mac version gigabytes of package of it, which is a Docker engine, which is important or which is necessary to run the Docker containers on your laptop. The Docker command line client, which will enable you to execute some Docker commands. Docker Compose, if you don't know it yet, don't worry about it, but it's just technology to orchestrate if you have multiple containers. And
I don't even know what orchestrate means, so I can just Google search it. The arrangement or scoring of music. Okay. I don't know what
there's stuff that we're not gonna need in this tutorial, but you'll have everything in version. Go ahead and download the stable version.
Okay.
Well, I already have Docker installed, but it shouldn't matter because the steps of installation are the same for both.
Okay.
So once the Docker DMG file is downloaded, you just double click on it, and it will pop up this window. Just drag the Docker whale app into that. As the next step, you just go ahead and Docker installed your applications.
Okay.
So you can just go ahead and start it.
Yeah.
Start it here. So as you see, the status that Docker is running, and your version, and you can just more than some error. I'm also gonna need Docker. I quit it from here, and then I started from other account, so that I don't get any errors. So that might be something you need to consider if you use multiple accounts. The first step, as I mentioned before, double check that you have other than you manually disabled it. So if you're unsure, then you can check it, or you can see the status of the virtualization.
I hope
so
it is
once
enabled.
you have checked that and made sure that these two prerequisites are met,
you don't have that option.
then actually you can scroll up and download the Windows installer from the stable channel. Once the installer is downloaded, you can just click on it and follow the installation wizard to install Docker for Windows. And the architecture tips of the system just push up and running, so you can actually have Docker whale icon starting, and if you're running, so this is basically it for the installation. Docker
I think
on
Windows is quite
Linux
easy.
distributions, and this is where things get a little bit more complicated.
Indeed.
So first of all, you see that in this menu on the left, you see that For different Linux distributions, the installation steps will differ. But also, for example, if we just click on Ubuntu for the guide, you can see that in the prerequisites section, there is also differentiation between the versions of the same Linux distribution. And there may be some even more complicated scenarios where the combination of the version of the distribution and the architecture it's running in also makes a difference into how to set up Docker on that specific environment.
Okay.
Because of that, I can't go through a Docker installation process of every Linux environment because there are just too many combinations. So instead, what we'll do is just go through a general overview of the steps and configuration process to get Docker set up. So these are some general steps. First of all, you have to go through the operating system that applies for you. Second step in the documentation is to uninstall old versions. Sorry about that. You also don't have to worry about the supported storage drivers, and you can skip ahead to the part of any Linux distribution. Here, the steps will be, or the options to set up a repository. I wouldn't recommend a lot of steps of the installation and the maintenance of the versions manually, so I wouldn't do that. The third one is just for the testing purposes. It may be basically just downloading Linux to the repository, which is downloading it from this to set up the repository you have, and then install the Docker CE from that repository. Enabled. Once you have that checked, Docker machine, Docker toolbox on its run environment. I mentioned previously, there is a workaround which is called Docker. So this is how to install the installation of Docker toolbox, which is basically.
I'll just skip it for now. I don't feel like it's worth it.
So in this video, I'm going to show you some basic.
The reason is I will most likely forget all of it, so it's better if I just don't study.
Docker commands. At the beginning, I'm going to explain what the difference between container and image is, because that's something a lot of people confuse. Then very quickly go through version and commands that will be enough to pull an image locally, to start a container, to configure a container, and even debug the container. So with that said, let's get started. So what is the difference between container and image? Mostly people use those terms interchangeably, but actually there is a fine difference between the two. To see theoretically, container is just a part of a container runtime. So container is the running environment for an image. So as you see in this graphic, the application image that runs the application, it could be Postgres, Redis, some other application, needs, let's say, a file system where it can save the log files or where it can store some configuration files. It also needs some environmental configuration like environmental variables and so on. So all of this environmental stuff are provided by container. And container also has a port that is binded to it, which makes it possible to talk to the application which is running inside of a container. And of course, it should be noted here that the file system is virtual in container. So the container has its own abstraction of an operating system, including the file system and the environment, which is of course different from the file system and environment of the host machine. So in order to see the difference between container and image in action, let's head over to the Docker Hub and find, for example, a is that Docker Hub, all the artifacts that are in the Docker Hub are images. So we're not talking about containers here. All of these things are images, Docker official image. So we're gonna go ahead and pull a Redis image out of the Docker Hub to my laptop. So you see the different layers of the image. Take a couple of minutes. Check all the existing images on my laptop. Using Docker images command. So I see I have two images, Redis and Postgres. Aspect of images is that each image the latest is always the one that you get when you don't specify the version, of course. If you have a dependency on a specific version, you can actually choose the version you want and specify it. You can select one from here. So this is what you see here. The tag is basically the version of the image. So I just downloaded the latest, and I can also see the size of the image with images there. Let's say I need Redis running so that my application can connect to that. Will make I can do it by running the Redis image. So if I say docker run Redis, this will actually start the image in a container. So as I said before, container is a running environment of an image. So now if I open a new tab and do docker ps, I will get status of all the running Docker containers. So on the image or the port that it's running on. The docker run Redis command will start the Redis container in the terminal. The control C. You see the Redis app. Do docker ps again. Docker run command that makes it possible to run the container in a detached mode, and that is minus. Just get the ID of the container. image mode. Now, for example, if you would want to restart a container because, I don't know, the application crashed inside or some error happened, so you just the first part of it, not the whole string. And you can simply say docker stop ID of the container, and that will stop the Docker container. Nothing running. If you want to start it again, you can use the same ID to start again. Start again. So let's say you stop a Docker container. At the end of the day, you go home, you come back the next day, open your laptop, and you want to restart the stopped container, right? So if you do docker ps, the output is empty, you don't see any containers. So what you can do, alternative to just looking up your history, command line history, is you can do docker ps -a, which will show you all the containers which are running or not running. So here you see the container ID again, and you can restart it. Let's say you have two parallel applications that both use Redis but in different versions. So you would need two Redis containers with different image versions running on your. Have the latest one, and let's head over to the docker 4. Redis image. We did docker pull Redis. However, if you use docker run with Redis image and the tag which was it will pull the image and start the container right away after that docker start image locally, so load it and the container. You see that I have two Redises running, so this is where it gets interesting. Now, how do you actually use any container that you just started? So in this output, you also see the ports section, which specifies on which port containers listening to the incoming requests. So both containers open the same port, which is what was specified in the image. So in the logs of the 3 while both are running on the same port. So to explain that, let's head over to our slide and see how this works. As you know, container is just a virtual environment running on your host, and you can have multiple containers running simultaneously on your host, which is your laptop, PC, whatever you're working on. And your laptop has certain ports available that you can open for certain applications. So how it works is that you need to create a so-called binding between a port that your laptop, your host, host machine has and the container. So for example, in the first container part here, you see container is listening on port 5000 and you bind your laptop's port 5000 to that containers. Now, you will have conflict if you open two 5000 ports on your host, because you will get a message the port is already bound or is already in use. You can do that. However, you can have two containers, as you see in the second and third containers are both listening on port 3000, which is absolutely okay as long as you bind them to two different ports from your host machine. So once the port binding between the host and the container is already done, you can actually connect to the running container using the port of the host. So in this example URI, you would have some app, localhost, and then the port of the host, and the host then will know how to forward the request to the container using the port binding. So if we head back, here you see that containers have their ports and they're both running on the same one. However, we haven't made any binding between my laptop's port and the container port. And because of that, the container is basically unreachable by any application, so I won't be able to use it. So the way we actually do that is by specifying the binding of the ports during the run command. So I'm gonna break this and stop the other one as well, so we can start them anew. Are here, so now we want to start them using the binding between the two Redises. So we need, the way to do it is port of the host, that's the first one. So let's go with 6000, it doesn't really matter in this case. And the second one is the port that you're binding this to, which is the container port. So we know the container port will be 6379, and this is where we bind my laptop's port 6002. And if I do this, I forget Redis here. So, and now if I do docker ps, let's actually clean this, docker ps again. Here you see the binding here, right? So your laptop's 6000 port is bound to the containers 6379. So now let's do another thing and let's start it in a detached mode. So like this. Let's check again. It's running again, and now I want to start the second container. Let's clear this again. When I specified different options with the port mode here, for example, if I were to enter with the same port on my laptop, I can do 6001 and run it. Again, I'll run it in detached mode. So go over here and say docker ps. I see that I have two different Redis on my laptop and the containers themselves listening to request on the top port. So far we have seen a couple of basic Docker commands. We have seen docker pull, which pulls the image, which basically combines docker pull and docker start. Pulls the image if it's not locally. Available and then starts it right away. Then we saw docker start if you made some changes and you want to create a new version, run, which is terminal again. First comes the port of your Docker PS running current is that you have stale Docker. Final part of the Docker basic commands are commands for troubleshooting, which are container with some commands on it. So let's not have any output. We notation cannot see what logs. You can also do the local logs if you don't want to remember the container ID or do Docker PS all the time. You can remember the name of the container and you can get the logs using the name. So a little side note here, as we're talking about the names of the containers. So here, as you see, when a container is created, you just get some random name like this. So you can name your containers as you want using another option of the Docker run, which might be pretty useful names. Let's create different and run it in the detached mode to and version, let's call it Redis folder. And we need to specify the image. So remember, this will create a new container since we're running the docker run command again. So if we execute this and check again, we see the Redis 4.0 image based container is created, which is refresh here, you can see it created, and the name is Redis older, and we can do the same so that we kind of know latest, and I will find. So here I have if folder, and in debug exit, and we have two containers and file or maybe whatever. So in order to do that, we use docker exit command or maybe container, and I want to get a terminal of the container and to maybe navigate a directory inside, print out the environmental variable command with -t, which stands for interactive terminal. Then I specify the container ID and I say bash, so I get the bash. And here you see that the cursor changed, so I'm inside of the container as a root user. And here, if I say ls, okay, the date is empty. I can also print out in which directory I am. I can go to the home directory, see what's there. So I have my virtual file system inside of a container. And here I can environmental variables to see that something is. This could be really useful if you have a container with some complex configuration container and you want to validate that everything the same using the name. Again, if you don't want to work with the IDs and you just want to remember the names of the container to make it easier, you can do it with the name as well, same thing. Since most of the container images are based on some lightweight Linux distributions, you wouldn't have much of the Linux or some other stuff. So options installed here, for example, you wouldn't have it in that sense, so you can execute a lot of stuff. It should be actually enough. Start, which might be confusing, where you create an image, an attribute with containers. So for example, as we saw, the port binding, and then you have tell Docker at the beginning what kind of container with what attributes. And once the container is good, so for example here the ID, and when you start it, the container will retain all the attributes that we defined when creating the container using docker run. So docker run is to create a new container, docker start is to restart a stopped container. So once you've learned the Docker basic concepts and understood how it works, it's important to see how Docker is actually used in practice. So in software development workflow, you will know you have these classical steps of development and continuous delivery or continuous integration, and then eventually it gets deployed on some environment, right? It could be a test environment, develop environment. So it's important to see how Docker actually integrates in all those steps. So in the next couple of videos, I'm going to concentrate exactly on that. So we're gonna see some overview of the flow, and then we're gonna zoom in on different parts and see how Docker is actually used in those individual steps. So let's consider a simplified scenario where you're developing a JavaScript application.
I just realized I was muted all along. That's such a messed up thing, man. I was muted all along. Damn. I guess I should take a break. That's it for today's stream. See you all tomorrow.